Welcome to the Open Source Technology Center. I'm your host, Dan Feinberg, and I'm joined once again by Eric Kazmarek and Soji Denloye. We're here to talk about big data technologies, and we're going to specifically drill down on Java for this particular video. Eric, can you tell us what Java is and why it's important to application developers?
The big difference with Java as compared to everybody else is that there's an abstraction layer between the application itself, the language, and the platform. This allows software engineers to write their code independently of the hardware, underneath hardware or OS and so on, right? That means you can write your code once, technically, and run it on a Intel device or on an embedded device or on your cell phone or anywhere else.
So it sounds like there would be a lot of overhead associated with that.
That's right. So originally, back in the mid-90s, Java was essentially an interpreted language. That means they would read the specific bytecode and executed C code as to kind of an abstraction layer. Since then, back in late 90s, 98, I think, 96, there's an idea of a JIT, just-in-time compiler within Java. That means when you code execute, your bytecode will eventually produce native code as if it was run built in C or C++. That's where most of Intel value is being added by modifying, optimizing this compiler to run best on IA platforms.
Well, and I've heard, Soji, that the work we've done over the years has actually increased the performance of Java by 32 times on Intel Xeon processors. Can you tell us a little bit about what some of that work was?
Whenever there's new instructions get added to the Intel instruction set, we also enable them in the Java virtual machine so that, like you said, the compiler can take advantage of this and your code can run 32 times faster. So some of these optimizations include vectorization. We've also done some work on locking. We've done some work on the ASNI instruction to accelerate encryption. Those are some of the optimizations that we've done recently.
And what are some of the practical ways that those optimizations are experienced by an application developer or an end user?
One of the ways is now an application programmer doesn't have to worry about doing all of this stuff themselves. Well, if the virtual machine didn't take advantage of, for example, the ASNI instruction, and an application programmer wanted to take advantage of this instruction, they would have had to go through the JNI or Java Native Interface. That's a lot of development time, so we pretty much save the developer a lot of hair pulling and a lot of time by doing this.
I see. Now, Eric, I understand that Java has importance to developers and to Intel not only because of Java itself, but also because it's an essential ingredient to some other big data technologies.
That's right. Most of today's big data frameworks, Hadoop, HBase, Cassandra, Hive, Spark, and so on, they all run on top of Java. They're not necessarily written in Java language, but they all run on top of Java virtual machine.
So in the next chapter in this video series, we're going to drill down on the performance optimizations and enabling work that Intel is doing on Hadoop and then the NoSQL data stores. I hope you'll join us then. Thank you.